Alright, this is Justine here. We're going to try doing a bunch of online videos for you guys so that you can check these when you're either having confusion in class or maybe you're absent for a day. So what I'm going to start off by talking about is graphing. So for graphing notes, we're going to start off by talking about the generic equation for circles. So the generic equation for circles is x minus h squared plus y minus k squared equals r squared, where h and k are coordinates of the center. So then we have semicircles. Oh, also r is the radius. When we do semicircles, we basically go ahead and we solve for y. So we have exactly half of a circle. So what you're going to do is do y equals plus or minus, because we can have the top, which is plus, or the bottom, which is minus, the square root of r squared minus x squared. And we're going to make sure we're centered at the origin, so you won't have to worry about any weird x minus 5 squares in your radical, okay? Or y plus 7, let's say. So remember that the plus right here, this means whether you have the top half or bottom half. So top half or bottom half. Top being positive, bottom being negative. Alright? So I'm going to pause and have you guys graph that first one. That way you can save a little bit of time. So just make sure to remember the center. And remember that when you do this, for the center, you want to do the opposite. Whenever anything is in parentheses with a variable, you're always going to do the opposite. Okay? So I'm going to pause real quick and I'll graph it, and then I'll talk about it. Alright, and here we have the circle. So remember when it says plus 2, that really means minus 2, so negative 2, and then minus 3 up in the top actually means regular 3. So your center is negative 2, comma, positive 3. And then you plot that as your center. Then you just make sure to square root your r squared. So that gives us a radius of 2. Alright? So when we're doing the next part, we're doing semicircles, because as you'll notice, we have square roots here. So one thing that I'll tell you is usually when it says bases, what we really mean, or what I'm going to take that as meaning, is whether we have the top half or the bottom half. So what part do you actually have? So I'm just going to say, I'm going to kind of cross this out and say what half we have. So I'll do number 2 with you, and then you can do number 3 without me. Okay? So for the first one, we have a positive square root, which means that we actually have the top half. So top half. And then it asks about the radius, which is going to be located right here. And we need to just square root 9, which gives us a radius of 3. So we're just going to go through and we're going to graph. So because I said we're centered at the origin, we don't have anything in with the x or over with the y. We're going to go through and just do the origin. And then our radius is 3. So 1, 2, 3. 3. 1, 2, 3. Then try your best. Mine never look very good, but we just deal with it. Okay? So now I'm going to pause and have you guys graph the second one. Alright, and here's the bottom half. Okay? So remember the plus or minus tells you top or bottom, and then the only number that's going to appear in your semicircle is going to need to be square rooted to get yourself a radius. Okay? Alright, now we're going to move on. So basically what we're going to do, now let me double check that I didn't miss a page. Oh no, we're on the correct page. Okay, so now what we're going to do is we're going to graph each function and we're not going to use a calculator. So what we're going to do here is I'm going to go through and I'm going to graph them based on their transformation. Okay? Now for people in this Beans class, I'm going to actually go through and show you how to use a table to help you. Okay? I didn't do that in class, but I know that it might be a little bit easier for you guys if I show you how to do that. Okay? So what we're going to do is just make our basic ordered pairs, and we're going to use that table in order to do the shifts that it's talking about. So in number 4, we basically have what's called a quadratic. So a quadratic has ordered pairs, y. Usually I do at least 3. I know way more than that when it comes to a squared function, but I'll do that. Negative 1, 1, 0, 0, 1, 1. I will tell you that if this is not memorized at this point, it most definitely has to be. You need to know at least 2 to 3, depending on the function, ordered pairs in order to graph these functions, and you will have to have it memorized. So that function BFF piece of paper, you actually really need to memorize that if you don't know it already. Okay? So what we're going to do is use this table. So we're going to go to all of these ordered pairs, and we're just going to do the shift that it says. So what this says is minus 3. So when you're inside with the x value, when you're inside with the x, you're always doing exactly the opposite. So this is right. Oh, geez. Oops, sorry. I'm going to go ahead and erase that. Let's try it. Okay. So this is right 3. And this part means up 2, because when you're on the outside or not in with the x, you do exactly what you say, and you're talking about y. So up 2. So right 3 and up 2. So I'm going to take all my ordered pairs, and I'm going to go right 3 and up 2. Okay? For quadratics, I usually start with my middle point, so I'm just going to do that. So right 3, 1, 2, 3, and up 2. And then plot the other one, so right 3, up 2, from all of your given ordered pairs right here. Okay? I know the pattern for a quadratic, so I'm just going to go ahead and graph it a little bit quicker. This should be something you're pretty good at. There are lots of different ways of memorizing it. Since there is no multiplier right here, there's no number right here or inside with your x, it should be pretty simple to go ahead and do. Okay? All right, domain and range. The domain for quadratics are always all real. Okay? The range for this one is y is greater than or equal to 2. Remember, bottom to top. Lowest is 2, highest is infinity. Okay? So now I'm going to do the same exact thing with number 5. So I'm going to use my table. Okay? So use my table. And then we have to go through and we have to remember our ordered pairs for a cubic. A cubic is -1, -1, 0, 0, 1, 1. If you can't remember what they are, remember you can just, this is a cube function, so take your x value and cube it. Even if you don't have it memorized, you can go through and write them down. Now, the one thing that I didn't talk about in class, remember this is Miss Bean, the one thing that I didn't really talk about in class was how to go about with these multipliers using a table. Okay? So the table is the one thing that I use when we have this multiplier here, like this thing that says times 2. Okay? So what we can do here is we can actually go through. So this times 2 is exactly the opposite. We did talk about that. So these are opposites. This actually means divide x's by 2. Or you'll see me usually say multiply by 1/2. Okay? So I'm also going to put in parentheses multiply by 1/2. I usually say that. 1/2. Still the action, okay? Alright, so all I'm going to do is take this table, this blue one, and I'm going to multiply my x's by 1/2. Okay? And then I'm just going to plot the ordered pairs because it doesn't tell me to shift up, down, left, or right. So I'm just going to take this. I could rewrite it, and actually I will for you just in case. So I'll rewrite it. So my new one is going to be 1/2, 1, 0, 0 still, and then, oh, sorry, -1/2, and this will be +1/2. +1, let's fix those. Okay, now my signs are all good. So I'm going to go -1/2, then -1, 0, 0, 1/2. Okay, and then I'm going to plot it. Okay, so domain and range of cubics is always going to be all real for both. Okay, so these tables here, you use them when you have a multiplier. So this is a multiplier right here. This 2, I'll go ahead and highlight it in like orange. This is what we call a multiplier, okay? And you can have it in or out. Remember, inside you just do the opposite, outside you do exactly what it says, okay? Inside with x's and opposite, outside with y's, and exactly what it says. Okay, now let's look at number 6. And number 6 is the square root function. So what I'm going to do is I'm going to write a table. And remember, I have these memorized. So we want to remember a couple, usually 0, 0, 1, 1, 4, 2. Okay? So what we have here is we have a multiplier, and this is the only thing I'm going to deal with in the table. So it says 3, and it's on the outside. So what that means is we're going to multiply our 3's, multiply our y's, by 3. All right. Now I'm going to rewrite that table. X, y, 0, 0, 1, 3, 4, 6. Okay? And then it tells me I need to shift down 1. This is a down 1. Okay? So right here, it says down 1. So I'm actually just going to go to plot the ones that I have, and then I'm going to go through and I'm just going to shift it down 1. So it says 0, 0. So I'm going to go through and I'm going to shift down 1. So 0, negative 1. And then I'm at 1, 3. Over 1, up 1, 2, 3, and then shift down 1. Then I'm going to do 4, 6. 2, 3, 4. 1, 2, 3, 4, 5, 6. But I need to shift down 1. Okay? Perfect. So now what we have right here, number 7, is called a reciprocal function. So number 7 is kind of a little bit different because these shifts here, these shifts are actually really occurring. So this will move asymptote. Down 3. Okay? And then this one right here, this plus 4 is with an x, so remember it's the opposite. So this means we're going to go left 4. So I'm going to pause real quick and I'll draw those in. Alright, so now we've got our asymptotes graph, and we're going to go through and plot the functions. So one thing I will tell you is that when you're doing a reciprocal function, if this is 1 right here in the top, then you actually just need to go exactly over 1 and up 1, or over 1 and down 1 in each corner. And we always go left bottom to right top if it's a positive up here. So if this is positive, this part here, then you're going to go through and you're going to do left, bottom, right, top. And then honestly, you can just go through and get it. It's the boolean function, is what I like to call it. Try and keep your function getting closer to your asymptote. That didn't work out for me. Okay? All right. So now we're going to do this one. This one is a little bit different just because we've got a 2 inside of our function here. So something that's special about this one is we have to go through and we actually have to factor out the 2 inside of here. So we're going to factor it out. 2 times x minus 6. Great. Then we have our negative out front. So we're going to use a table just like we did before because it'll be a little bit easier, I think, for you guys. I should have done this one before, but you live and you learn. So we have, this is square root, so we have 0, 0. We have 1, 1, and we have 4, 2. Okay? So remember, only the multipliers really get done in here. Oh, good thing I noticed. Got to factor out correctly. So we have 3. Okay, great. Now we'll go ahead and do our multipliers on here and then shift when we get to the graph, or graph. So we have this one right here. We have our 2. Remember, our 2 is inside the function. That's inside the square root with the x, which means we'll do exactly the opposite. So we're going to take exactly half. Okay, so we'll multiply by 1/2. We'll multiply by 1/2 again. Multiply by 1/2. Okay, And then it tells us on the outside, so on the outside right here, this will multiply y by -1. Or I can just put negative sign. Negative, negative. Okay? And I'll go ahead and rewrite the figures. Multiply x's by 1/2. Remember, because it means opposite. Alright, so now we have a new table. So we have x, y. Okay? And then we'll just rewrite. So we have 0, we have 1/2, we have 2, and then we have 0, -1, -2. So remember, because there is a shift, it looks like we have a shift right here. Right here tells us to go right. We'll go ahead and do that. So we'll go right by 3. Okay? So I'm going to go to 0, 0. And then I'm going to shift right. 1, 2, 3. Done. So it says 1/2, -1. So 1/2, -1, and then move over 3. 2, 3. Okay? And then 2, -2. Over 3. Okay. Then I have my function. And then we just need to do the domain and range. So, unfortunately, I have my tables kind of in the way, but it's okay. I'll still write them. I'll just go below it. So, I have domain. It looks like x is greater than or equal to 3. And then our range, this is actually going below, so it's going to be y is less than or equal to 0. Below the x-axis. Okay, now let's do the step function. So the step function, when we're going through and doing that, this is called the greatest integer function, or it looks like steps, as I was saying. So what we do for this one's actually kind of an interesting one. I like this one. So things that you have to do is you have to go through and you have to take, we don't usually use a table for this one, remember. So this one is to multiply x's by 3. And this one is to move this recording thing out of the way. Multiply y by 2. And this part right here means to shift the whole function down. So shift down. One. Okay? So what we usually have is it looks like this. I'll draw it really quick, but then I'll get rid of it. So usually it starts here, it goes over here, and it's open. Just a length of 1. So because our length of 1 is the only thing that we have that really goes with our x values, right, inside. So for x values, we're going to multiply, and we're going to make the length of this one 3. So now it's going to be a length of 3. So all of our stairs are going to be a length of 3. And then that 2, when it says multiply y's by 2, we're actually going to space them out by 2. As opposed to being a jump of 1 space, we're going to jump up 2 in between each one. And then this is a shift down 1, which means take our whole function, instead of starting on the x-axis like we usually do, we're going to go through and we're actually going to start down. So for example, I'm going to go here, I'm going to go a length of 3, still open circle like normal. Okay? Then I'm going to jump up 2, that's where that 2 came from. Then I'm going to jump up 2 again, and then I'm going to jump down 2 over length of 3, remember? And then I'm going to, shift down, okay, great. And then walk 3. Okay. Alrighty, so the domain for this one, it's kind of a really weird looking all real numbers. So basically fill all the holes that we created. Now the range is actually a really interesting one. So the range is going to be all the odd numbers. all the odd integers. So if you're going to do all the odd integers, the way to show odd is to do something like this. So you do 2n plus 1. But because n is going to be an integer, we're going to go 2v plus 1. And I always put this little part on here to show that it's a v, okay? So 2v plus 1. I wouldn't worry too much about the notation for that one, but I just wanted to show you. Okay? All right, now let's move on to our piecewise functions. I know we were having a couple issues with those. So what I always start with is I go through and I do the barrier line, or I like to call it my fences. That's right here. So the two values I have for my fences that separate my functions are -1. And I should kind of like an asymptote, but it's actually really just showing where the division between the functions are. And then 1 right here, okay, which means we have 3 separate areas for 3 separate functions. Okay? Alrighty. So now we just need to graph them. So if I look at number 10, the first function where it says x is less than -1, that's going to be on the left side. It tells us it's a quadratic that's been shifted down here. So all I have to do is make sure that that happens, okay? So the quadratic, and then it's been shifted down too, okay? So what I do usually is I go through and I actually plot the function, and then I erase it for the areas that it shouldn't be. So I want you to plot x squared minus 2. I'm going to pause. Okay, so this is what we should have originally, okay? But what you notice is it says that it only exists right here, which is on the left side. So what I need to do is I actually need to go through and I need to get rid of these other dots. So they don't belong there because it only exists over here. And actually I need to fix this dot because it says right here that it's just less than, which means that I should go through and it should be an open circle. Then I go through and I just plot the rest of it, right? And now I'm going to do the same exact thing with the middle function. So the middle function I'm going to do in green here. This is just a line with a slope of -1 going through the origin. So I'm going to go origin. And the slope of -1 is up and to the left. And then down and to the right. And I have all of them closed. I need to double check. Closed and closed because they're under. Right? And then I'm going to go through and do the last one. So the last one says x minus 2 in parentheses squared. So this means I've shifted to the right 2. Okay? I've shifted to the right 2. Alright? So that shifts me right 2. And then I need to go through and just plot the function. So plot yourself a quadratic, which is what we did with our blue one. Okay? I'm not going to tell you how to do that because we should know that already. Okay, and now when we do the range for this one in the domain we cover all the holes that we have, so we're going to go all real numbers. But range, we need to look at our lowest. Our lowest looks like -1 with an open circle for blue, but they closed it down at green. So we're going to go -1 is less than or equal to y, which is less than, oh, I don't like this. Okay. Okay. I'm going to do it in interval notation. So it actually goes from -1, close, to infinity. Perfect. Okay? I don't like putting infinity in mine, so like, oh, I guess I could have, well, it's fine. You could also say y is greater than or equal to -1. Okay? So I'm going to pause and see what you can do in number 11. And I'm going to go ahead and do number 11. Should have for the second one. Okay? So, we did -x minus 2, that's a line. That has a y-intercept of -2, and then it has a slope of -1. Okay? And then -4 is just a dot at x equals 1. And then x squared plus 1 is a quadratic that's been shifted up 1. Okay? For domain and range. So domain, it stops at -4 and then continues on forever. because we keep going to the right. So it's going to be x is greater than or equal to -4. And our range is going to be a little bit odd. So we'll call it y equals -4. And then y is greater than -3. It's an open circle, so not or equal to. Okay? Alright. Now we're going to go through and we'll finish up the last problem. Okay? So then it says g, what is g of -4? We're using the function to the left, so it says what is g of -4? It wants to know if 4 is the x value. It wants to know what is the y value. So I'm going to go to 4, 1, 2, 3, 4. Where is it? It's right here, which means our y value is 1. Okay, so I'm going to write g of 4 equals 1. Okay, says is g of -2 positive or negative? I'll do this one in green. So remember -2 is the x. So let's find -2 right here. Lift up. So that's going to be positive. Right? And it says for what numbers of x is g of x greater than 0? So remember g of x, the whole thing just stands for y. Okay? So it wants to know for what numbers of x is y greater than 0? So it's asking where is this function above the x-axis, or where is y greater than 0? So one thing that you can do, let me see if I can show it here, you could actually do some sort of shading. So like this part is above, okay? And then that, because then it goes below. This part is also above, okay? And then this part is also above, all right? So we need to know the x values there. So for what numbers of x, and says use interval notation. So we go from -infinity until 1, 2, 3, 4, 5 to -5. Remember we use soft brackets the whole time. And then -3 to 1. And then we have from 3 to 5. Great. Now it says, what is the domain of G? So the domain of G, if we're talking about domain, remember that's left and right, and we have arrows on both ends, which means we have -infinity to +infinity. Okay? Then it asks us for the range, and the range, since we have arrows, is actually exactly the same. -infinity to infinity. Okay? Then it says, what are the x-intercepts? I will tell you, generally I use ordered pairs for these. So if you could do the same, it won't hurt either way, but I just tend to use ordered pairs. So this one's going to be -5, 0. There are a lot of them. And then -3, 0. And then 1, 0. 3, 0. And then 5, 0. Oops, that's it. Okay. The y-intercept I actually also go through and use as an ordered pair. I'll put here. Just make sure to write it correctly. It's 0, 2. And then how often does the line y equal 2 intersect the graph of G? So what you can do is you can actually go, let me find a color I haven't used yet. We'll use this maroon color. So y equals 2 is right here, so I'm going to go through and I'm going to draw myself a line. And y equals 2, remember y equals 2 is horizontal. So how many times does it intersect the graph? It looks like it hits it 3 times. All right. For what values of x does g of x equal -2? So remember, this part right here, I'm going to have to go to purple because I don't really have these colors. So g of x just means y when it's all together. So y equals -2. So where is y -2? Well, like down here. So what x value? That would be x equals -4. Okay? What are the local maxima? So local just means list all of the tops. So what we're going to do, I'm going to use brown because I'm really running out of colors. But they just want to know where are the tops of the hills. So right here it looks like. And right here, I'll make it around here. Okay? So you can make a guesstimate, your best guesstimate for the one on the left side. It looks like it would be like -1.25, comma 4. I'll just call it 4. It looks pretty close. We'll be somewhat lenient on that as long as you're close on those. And then the other one looks like it's 4.1. That one's a little nicer. Okay? Now it says on which intervals is G decreasing. So this is actually an algebra 2 question, but let's see what we can do here. So, sorry about that. Let's go back here. So when we're doing that, we want decreasing. So decreasing, we'll use gray, or we'll use light purple. So decreasing is right here, so going down. So this section right here is going down. This section right here is going down. And this section right here is going down. Okay? So decreasing looks like from -infinity to -5. And then it looks like from, well, we call that -1.25, so we're going to have to go with that, -1.25, until it looks like 2. Remember, these are x values. And then 4 to infinity, because they're x values. Okay, 4 and beyond. Okay, that's all for these notes. So sorry it took so long.